Okay, there's something wrong with my logic, because this just isn't right. Okay? So in yellow, I've outlined what's right. We're going to let x be this vector, right? So this vector is a times x. And x is the vector we want. This is the vector we're trying to find. Okay? So here's ax, and here is w. W being your y datum, the vector of your y datum. We want this to be as close as possible to this, which means that this vector has to be orthogonal to this space. Well, what's orthogonal to this space? The null space, right? Let's talk about projecting this vector onto the null space to get this vector, but it's just ax minus w if you want to go to those symbols, okay? And ax minus w, in order for x to be the vector you're looking for, has to be perpendicular or orthogonal to this subspace. Okay? Meaning it has to be in the null space because the space here is a direct sum of this space and this space. Okay? So your condition becomes simply that this is in the null space of A transpose. Well, if it's in the null space of A transpose, then if you multiply it by A transpose, you get 0. And then just by the linearity, this tells you that A transpose A, which is a matrix you can easily calculate, it's an n by n matrix, multiplied by the x vector, which is what you're trying to find, equals A transpose W. Okay? Then hopefully A transpose A can be inverted. And if it can, then you've got a solution, right? Even if it can't, you can write this out as a system of equations, n equations and n unknowns, and get a solution. And the geometry is as I've said it, but somewhere in my previous attempt at an explanation, something got messed up. And I've got to sort that out, and I'll tell you about it next time after I sort it out. Okay? I'll save this board so I can explain it, both to myself and to you. Everything here is pretty much right, again, except my logic from here to here and back. Get this, something screwed up.